Hi, Ruth. Take it away.
Thank you. Can I ask a question for Nick? In your slide, I see you plotted acidic crust, oxygen fugacity as an average with uncertainty. So, do people have observed heterogeneity within the acidic crust samples just internally, or it's very consistent, just converging at the same value?
In terms of the oxygen fugacity, I mean, the challenge is that the method requires coupled major and trace element data sets, and that's the only data set I could find. So that's one sample, and the uncertainty is calculated using Monte Carlo simulations that propagate all the inputs through the oxybarometer. But I will say that the same group at ETH that I mentioned, they have applied Zane's techniques to look at some of these lunar north sites, and they appear to be relatively reduced.
Yeah, this is because I think it's an important issue because even within the crust, there is differentiation because there's some early crust, some later crust, some primitive, some evolved crust. If actually there's a resolution that can say a different, and so say samples have a variety of the oxygen fugacity heterogeneity, that would be cool, just additional evidence to support the continuous differentiation in the later stage, I would say.
Yeah, that's absolutely right. And we should look at a whole bunch of different crustal samples. Thank you.
I'll resist asking Nick a question and instead ask a question about the dunite. So Mike, I'm Carl Agee, by the way.
Hello.
So I really enjoyed your talk. It was great.
Thanks.
So you're assuming that that lunar xenoliths are most from the mantle
this one's
coming out of impact basins.
Yeah,
and
that
you
was excavated.
You actually presented evidence that the impact basins, or at least the one that you showed, the big one, they're too hot.
Yeah.
And so, what's the likelihood that these xenoliths are actually coming, or this xenolith is not from an impact basin at all, but it's a xenolith that has been erupted.
Yeah.
That's how we see most of the xenoliths on Earth. So.
Yeah, true. And there's definitely some interesting space there to explore that. What we see from the texture of the dunite is that it is consistent with a pretty sizable shock event. But that could be that it was brought to the surface first through an eruption and then shocked. That's definitely possible. And that's something that, we're definitely considering. What we would really like to get to with that is if we could try to tease out if there was some pre-existing fabric that wasn't random, and then that was later overprinted by some sort of, shock event, because in this case, the shock would have occurred at very cold temperatures, respectively, assuming the sample was already erupted onto the surface in some basaltic deposit or whatever. The preferred orientation implied by a shock would be quite muted. And so that's something we're kind of currently working on, trying to understand and compare this specifically to terrestrial xenoliths and kind of explore any similarities that might exist. So definitely interesting, but I don't have a definitive answer at the time.
I want to follow up or ask a similar question, which is, there was a paper, I want to say a decade ago I think it was from the Cayuga folks, and they were looking at olivine exposures on the moon, or maybe it was dunite exposures. They found a lot of exposures associated with central peaks. In some cases, I think it was basin walls, they were seeing a little bit exposures.
Yeah.
Is there a way you could take your dunite and make a comparison of what it would, differences of what you would get if it was coming from a central peak or coming from the walls of a basin or something like that? Does it, how diagnostic are your constraints, maybe I'll put it that way?
Yeah. I am not sure at the moment if that's something that we could do. It would definitely help us provide a lot of context for this, which is something, I'm really interested in. But just thinking about it, I think we may be, kind of at the limits of what the data set can do at the moment. I don't know exactly what exactly we would need to test to be able to determine between the two.
Okay.
But
I have other questions, but maybe for time we should move on. I don't get to ask
you have
a
quick one.
Well, let's see. Related to this, I had after this Cayuga paper came out, I think I had a long talk with Mark Norman about this. And I said, were there any other dunite or olivine rich rocks that we had in our collection that would suggest mantle material and the rest? He said no. But the impression I got is that we had dunites, but there were reasons to think they weren't from the mantle.
Yeah.
What separates this one from those guys?
Yeah. Well, the big thing is just of dunites that exist many of them do not have the requisite, mineral assemblages to perform robust thermobarometry and place them to the mantle. They may be from the mantle. Could definitely be true, right? What separates mine is just we are more definitive in that assumption. There are definitely some dunites out there that are probably not from the mantle for other reasons, but I think it'd be obtuse to say that none of them are. Yeah.
Okay. Yeah.